Let's interpret the domain and range of real-world function graphs. Number 1. This graph represents the distance Ben travels from home in miles to visit 2 stores as a function of time. Step 1. Evaluate the graph, including the domain and range. This graph starts with the 0 distance from home at the time that Ben starts to travel, suggesting that he is at home, so he's not away from home, a distance of 0. As he continues to travel away from his home towards the stores, that we see he gets further and further away. Eventually the graph goes into a plateau, suggesting that Ben's distance away from home is staying constant. Perhaps this is where he's staying at the first shop, where he's only moving within a short amount of space. His overall distance away from home begins to change again as he continues to go further away and then plateau for a second stop. Once again, his overall distance from home plateaus, suggesting that his movement is limited to a small area. After about another 40 minutes, he is starting to get closer and closer to home until he arrives back home. The domain, which is the set of all input values, is between 0 and 4 because these are all of the values that have information on the graph. We can know his distance at the hour 2, but we cannot know his distance at the hour 5 because our graph ends at 4. So the domain starts at 0 hours and ends at 4 hours, and we can know everything in between. The range is all of the output values, and we see a minimum output value of 0 miles, and we see a maximum output value of 40 miles. So the range is between 0 and 40 miles. How did we evaluate the graph? We evaluate the domain by looking at the graph from side to side and seeing where it starts and where it ends, and we find the range by looking at the graph up and down and finding where its lowest point and its highest point are. In between, these are all of the input values and output values. Step 2. Interpret the graph to answer the questions. Between which 2 hours did Ben visit the first store? Explain. If the graph is increasing, going up, or decreasing, going down, then we know that Ben is either getting closer to home or further from his home. So if he is at a store, then that means his movement is confined to a small building. That means that the 2 times where Ben is visiting a store are when the graph is more flat than the increasing or decreasing parts of our graph. That means that the first store that Ben visited would occur here between hours 1 and 2. Ben visited the first store between the hours 1 and 2. I know because this is the first of 2 flat sections of the graph where his distance remained mostly constant. Did Ben ever travel 50 miles from his house? Explain. Taking a look at 50 miles on the distance side, we see here that there is no graph information for 50 miles distance, which means that Ben never traveled that far away. No, Ben never traveled 50 miles from his house. I know because the graph never crosses the horizontal line at 50 miles. Does the graph provide information about how far Ben was from his house after 5 hours? Explain. This graph does not provide any information about how far Ben was from his house at 5 hours. If there was information, we would be able to look at the hour of 5 and then look up and find a location of the graph at 5. But we also know that the domain is only between 0 and 4 hours, and so 5 hours is outside of that domain. That means 5 is not an input value that will give us an output value. No, the graph does not provide information about how far Ben was from his house after 5 hours. I know because the graph domain ends at the 4-hour mark, and overall the domain is only between 0 and 4 hours. You are now ready to interpret the domain and range of real-world function graphs for graph number 2.